used in microscopes, in binoculars, in refracting telescopes, in cameras, and so on. A double convex lens, also called as biconvex lens, is an optical device has two convex surfaces. A convex lens has two surfaces, first spherical surface and the second spherical surface. When we join the first spherical surface and second spherical surface, we get biconvex lens. Now consider ray diagram for first spherical surface. Now consider ray diagram for second spherical surface. After that, writing down equation for first interface ABC and second interface ADC. For first interface ABC, we get the equation N1 upon OB plus N2 upon BE1 equals to N2 minus N1 upon BC1, where N1 is the refractive index of the medium left side of ABC and N2 is the refractive index of the medium right side to the ABC, and the equation for second interface ADC is N1 upon Di minus N2 upon Di1 equals to N2 minus N1 upon DC2. Call it this equation 1 and call this as a equation 2. Now we are going to add equation 1 and 2. So this is the equation 1 and it is the equation number 2, that in both the diagrams Pi1, from diagram 1 and 2, Py1 equals to Di1. Therefore in equation 2 Di1 is replaced by Bi1. Therefore in place of Di1, now writing Bi1. Now these two terms are similar and one is positive, another is negative, so cancelling them implies N1 upon OB plus N1 upon Di equals to N2 minus N1 upon BC1 plus N2 minus N1 upon DC2, where OB is the object distance, Di is the image distance, BC1 equals to plus R1 and DC2 equals to minus R2. These plus and minus symbols are selected as per as Cartesian sign convention. Suppose we assume the object is placed at the infinity, then OB equals to infinity, and we know that when the object is at infinity, the image is formed as the focal point. Therefore, di is the image distance equals to f. That is, if OB equals to infinity, then di equals to f. Therefore, n1 upon infinity plus n1 upon f equals to here n2 minus n1 upon r1 plus n2 minus n1 upon minus r2. Therefore, n1 upon infinity plus n1 upon f equals to n2 minus n1 upon r1 plus n2 minus n1 upon minus r2. n1 upon infinity, this part becomes 0. Therefore, we get n1 upon f, and here n2 minus n1 taken common, we get 1 upon r1 minus 1 upon r2. n1 upon f, and in RHS side taking n1 common, so we get n2 upon n1 minus 1, here 1 upon r1 minus 1 upon r2. Both side n1 get cancelled, we get 1 upon f equals to n2 upon n1 minus n, and here 1 upon r1 minus 1 upon r2. Let n2 upon n1 is nothing but n21. Therefore, we get 1 upon f equals to n21 minus 1 upon r1 minus 1 upon r2. This is nothing but known as lens maker formula. Suppose now we bring the B and D close to one another, then the lens becomes thin and it is called as a thin lens. And in case of thin lenses, now we consider this equation once again, n1 upon OB and n1 upon DI equals to n1 upon f. Now from figure, OB is nothing but, that is BO, that is nothing but minus U, and DI is nothing but plus V. Therefore, n1 is taken common here. In place of OB, write down minus U, and in place of DI, write down V, and we have taken n1 common, n1 upon f, this and this cut down, so we get 1 upon V minus 1 upon U equals to 1 upon f. This is nothing but called as a thin lens formula. This is called thin lens formula.